James Webb Space Telescope will do a galaxy deep dive into the dust. The study will survey stars, star clusters and dust in 19 neighbors to the Milky Way. This image of spiral galaxy NGC 3351 combines data from observatories including Atacama Large Millimeter/Submillimeter Array, ALMA, the Very Large Telescope and the Hubble Space Telescope. The James Webb Space Telescope is due to study the galaxy within its first year of science observations. One of the James Webb Space Telescope's first studies will seek to tell us more about 19 nearby galaxies and how they fit into our neighborhood's history. The infrared images taken from deep space will allow Webb's data to add galactic information about star formation, strong winds blowing off these stars to disturb gas and dust, and mature stars potentially hiding in spiral galaxies. Webb is currently in the middle of a commissioning period, with engineers focused on getting its 18 hexagonal mirrors into alignment and slowly testing and turning on the instruments. That work is going well so far, NASA has said, and the expectation is Webb will begin science observations in the summer. JWST touches on so many different phases of the stellar life cycle, all in tremendous resolution. Janice Lee, Gemini Observatory chief scientist at the National Science Foundation's NOIRA lab in Arizona, said of the new study in a statement, "Webb will reveal star formation at its very earliest stages, right when gas collapses to form stars and heats up the surrounding dust." The Multi-Wavelength Galaxy Survey program is known as FANGS, Physics at High Angular Resolution in Nearby Galaxies. The program includes 100 specialists worldwide who are seeking to understand star evolution, from youngsters to maturity and beyond. The galaxies under consideration are visible face-on from Earth and on average, about 50 million light-years away. Multiple observatories have already studied these galaxies, each bringing their own talents to the analysis. That includes the Atacama Large Millimeter/Submillimeter Array, ALMA, in Chile, which has studied 90 galaxies in microwave light, letting astronomers map which molecules are found where. The Very Large Telescope, also located in Chile, has also taken part in the project with its Multi-Unit Spectroscopic Explorer, MUSE, instrument. MUSE captured the light fingerprint of 19 galaxies in the later stages of star formation, once the regions are clear of the gas and dust that impede many types of observations. And the iconic Hubble Space Telescope has also taken part, studying 38 galaxies in visible and ultraviolet light and offering high-resolution images. Webb's role will be to seek out those zones of the galaxies filled with dust, which are rich in forming stars but are difficult to view in other wavelengths behind infrared. Benefits of the study from Webb will include figuring out the ages of stellar populations, to build more robust statistical models of galaxy formation, and learning about the role of dust in forming galaxies, the study says. As a whole, this information will allow researchers to learn about the timeline of star formation and how that formation takes place in the context of a galaxy. Timescales are critical in astronomy and physics, Lee said. How long does each stage of star formation last? How might those timelines vary in different galaxy environments? We want to measure when these stars free themselves from their gas clouds to understand how star formation is disrupted. James Webb Space Telescope will study Milky Way's flaring supermassive black hole, Sagittarius. It flickers every hour, making it a challenging target for telescopes. The James Webb Space Telescope will study the weirdly flickering black hole at the heart of our galaxy, the Milky Way, which has proved elusive for existing telescopes to explore. Webb will join the efforts of numerous telescopes to understand the nature of the supermassive black hole called Sagittarius A, whose tendency to flare up on an hourly basis makes it difficult to image. Joining Webb investigators will be a team working with the Event Horizon Telescope, EHT, made up of 8 ground-based radio telescopes, which captured the first-ever image of a black hole, M87, back in 2019. Although Sagittarius A is closer than M87, its flickering nature makes the Milky Way's own supermassive black hole a much more difficult target, Webb officials said in a statement. While M87's core presented a steady target, Sagittarius exhibits mysterious flickering flares on an hourly basis, which make the imaging process much more difficult, Webb officials wrote in late 2021. Webb will assist with its own infrared images of the black hole region, providing data about when flares are present that will be a valuable reference to the EHT team. The flares happen as charged particles are accelerated around the black hole to higher energies, creating light emission. Webb, which launched December 25 and is in the midst of a months-long commissioning period, will eventually image Sagittarius A in 2 infrared wavelengths from a perch in deep space unimpeded by light. Since EHT is on the ground, the hope is the data collected from Webb will complement the ground-based network data and create a cleaner, easy-to-interpret image. Collaborators expect that Webb and EHT working together will provide more information concerning what causes the flares, which in turn could provide insights for studying black holes, solar flares or particle and plasma physics more generally. We want to know how the universe works, because we are part of the universe. Black holes could hold clues to some of these big questions, study principal investigator Farhad Yousafzadeh, an astrophysicist at Northwestern University in Illinois, said in the same statement. The first physical black hole ever discovered was spotted in 1971. The first EHT image of M87 in 2019 provided direct visual proof that Einstein's black hole prediction was correct, the press release stated. Black holes, the team added, are a proving ground for Einstein's theory, and the hope is this first collaboration between Webb and EHT will allow for more telescope time in space in future years.
Well guys, this video is over. I hope you enjoy, and if you enjoy, be sure to hit the like button. Until the next video, have a great time.